Howdy! In this video, we're going to factor these two expressions completely. So we're going to start with 5a plus 1 parentheses squared minus 2 times parentheses 5a plus 1 minus 3, right? So probably the first thing you notice is that we have this 5a plus 1 both here and here. So we're going to use that to our advantage. Now you can kind of do it two ways. You can introduce a substitution, or you can just leave it as 5a plus 1 and factor it with that. All right, so I'm going to do a substitution. So let's introduce a new variable. You can pick any letter that is not being used. So since A is currently being used, I'm going to choose X. That's easy. Let's let X equal 5a plus 1. Right, so X is a new variable. We're going to change each 5a plus 1 quantity to an X. So that's going to become X squared minus 2 times X minus 3. Now that should be fairly straightforward to factor. It's a trinomial, so we will set up two sets of parentheses. We'll put an X into X, which will multiply to that X squared. Now these numbers are easy, so I'm just going to say, okay, what two numbers multiply to -3? Well, the only options are -3 and +1, or -1 and +3, but we're going to go with -3, +1, because then those add to -2. My outside term and my inside term add to -2x. All right, so then to finish factoring it, we're not solving, remember here, this is not a solve equation, it just says factor. So to factor, we then need to go back and replace each of these x's by what we defined x as, which was 5a plus 1. So let's replace that first x with 5a plus 1, and then it's followed by the -3, and the second x is also a 5a plus 1, followed by a plus 1. So there's one little thing we could do to simplify here, and that is combine the constants. So 1 minus 3 makes -2 there, and 1 plus 1 makes +2 here. Now, an alternate way would have been to multiply that entire thing out and then factor it without doing any substitutions, but it would have taken quite a bit more work. So I'd encourage you to pause the video, try this one next on your own, and then see if we do it the same way. All right, so I'm going to do yet another substitution. I think this one I'll go ahead and call it U. That's a common letter used in math. We always put let in math if you're defining a variable. Let U equal to this repeated quantity here, which is a squared plus 2a, because then I can write this whole thing as, instead of a squared plus 2a in parentheses, I could call it just U. U squared minus 2 times U minus 3. Oh, look at that. It's the same thing, right? So we know that's going to factor into U minus 3 times U plus 1, which we then can go back and do replace that U by a squared plus 2a minus 3. And you really didn't even have to do the substitution. If you were able to do this in your head, that's fine. A squared plus 2a plus 1. All right. The question here is, it is factored, but is it fully factored? I don't know. Those are each independent quadratics, so they may factor further. Let's see. A squared plus 2a minus 3. That's going to factor into a product of two binomials. So what I'm doing right here is this one is what I'm focusing on. It's going to factor into that times that. So both will start with an A. What two things multiply to -3 but add to +2? So that would have to be a +3 this time with a -1. And then a squared plus 2a plus 1 factors into, oh, well, that's a special factoring formula, right? Because that's the same quantity times itself. Factors into a plus 1 times a plus 1, or you can just write it as a plus 1 all squared. So there it is, fully factored. And that's all for this video.